All right, I thought I would make this video to show or at least give a couple of hints on the assignment for interpreting remainders. This one especially, there's a couple of them that we didn't really get a chance to talk to in class too much about, and so I wanted to make sure and you guys could get some extra help on it. There's another way that when you solve a problem, you can at the end determine what to do with your remainder or another way to interpret it. So today we talked about 5 different ways in class, but really there's another way that will pop up occasionally, and that's when subtraction is involved. So this is actually one of the problems off the assignment. I just picked one to show you guys kind of as a freebie. I've actually worked this problem, but I'm going to step through you guys what I did on this problem. So this one says Lana had saved up 719 dimes and decided to spend them on sodas. If it cost 40 dimes for each soda from a soda machine, how many more dimes would she need to buy the final soda? So the first thing I thought about doing here was breaking this up into just breaking up into parts, thinking about what this is. This is something where I'm thinking it could be a division problem because, again, they're giving me a total, and that total is 719. So that was the first thing I thought of. And then the second thing I thought of was the part, which is 40 dimes. And so on this problem, looking at it, it really turned into part whole, where I had a total and I had a part, but I was missing a part. And so at that point, I set up 719 divided by 40. That gave me the answer of 17 with the remainder of 39. And you could tell I did my work there. Since 40 is already a friendly number, I was thinking about my 4s on this problem. And I broke it down and basically only had to do one fact off to the side. I had to do 40 times 7. So at the end of this thing, on the side over here, this is what I want you guys working on, is I did some labeling. So I put that 719, those were the dimes that they had saved, or Lena had saved. The 40 was the cost per soda. That's how many, it's going to take you 40 dimes to go buy a soda. The 17 was how many that she could buy. She could actually go buy 17 sodas. And then the 39 was basically the dimes that were left over from the total. She had 719, she had quite a bit of them. Well, she had 39 dimes that were left over. Well, at the end of this thing, I really had to go and focus on what my question was. My question was, how many more dimes would she need to buy the final soda? So it's kind of like, well, I've got to break it down and really think, well, what do they want to know? They really don't want to know how many were left over. They didn't want to know how many could she buy. Like right now she could buy 17. They wanted to know how many more dimes would she need to buy the final soda. So up there in the problem, I circled the words how many more, and I wrote the word subtract by it. And that's pretty common. When you see those words, how many more, you're going to think it's probably going to be a subtraction problem. And so on this problem, I thought, okay, well, what am I going to subtract? What are my 2 numbers that I need to subtract here? Well, I really thought about a couple of things that I labeled. If I know it costs 40 dimes to buy a soda, and then she had 39 dimes left over at the end, I really thought, okay, well, how many more dimes is she going to need to buy another one? She really is only going to need one because she had 39 left over. She really just needs that one extra dime to buy the 18th soda. Now, when they want just that, that was what they wanted on the question. So the answer ends up being 1. And that's kind of weird because you're like, well, I have all these numbers off to the side. I've got these 4 numbers. 1's not one of them, but it could be if you go and do this extra math problem, which turns out to be this one up here in the top right-hand corner. Now it's such an easy one because your numbers, you're only one apart there, so that's not too hard. But it could be on some of these division problems where you have to go and subtract, and the subtraction could be a little bit harder than this one here. And again, it just falls back on, do you understand what they want? Do you have a true understanding of what that question wants? And the kids that normally have a true understanding, they're good readers, they're good mathematicians, they truly understand what that question is asking. And so on this one, if I labeled everything off to the side, then the only thing that makes sense to me is to think, well, if I had 39 dimes left over, or Lena did, and again, you got to think sometimes, hey, what if you were in this problem? What if it were you? So that's why I said if it were me, if I had 39 dimes left over and it costs 40 to buy a soda, I just need one more to buy another one. So that's what they wanted on that problem. So there's one freebie. All right, and this second problem, I'm going to kind of take you through it step by step. I'm not going to show it at the beginning. I'm going to show you how you would work this problem. Okay, so it says a container can hold 35 orange slices. If a company had 496 orange slices to put into containers, how many more slices would they need to fill up the last container? Okay, so on this problem, I've got to stop and think, all right, they've given me a total here, 496 orange slices. They've given me a part. They're going to go put 35 of these orange slices in a container. And then I have this question again, how many more slices would they need to fill up the last container? So I'm already maybe thinking about that statement right there, how many more? This could be a subtraction problem. And so I'm going to think at the beginning, I've got to do something before I get to that subtraction. I've got to think, all right, if I take 496 and I divide it by 35, I've got to understand, what am I doing? Well, I'm taking my total, 496 orange slices, and then I know that a container can hold 35 slices. I don't know how many containers they have, though, until I go solve this problem. And so on this problem, I'm dividing by 35. I can look at it as 35 can't go into 4. It can go into 49 just one time. 35 is going to go underneath. I'm going to subtract here. I'm going to follow my division steps. It looks like I'm going to have 14 left over from that. I can compare. 35 is bigger than 14, so I'm ready to bring down the 6. And now I have to think, how many times will 35 go into 146? Well, my 35s could be kind of like my 40s. I could think, skip counting by 4s maybe, and maybe think, all right, how many 4s can get up to maybe 14 instead of 146? And so I'm thinking probably like 3 or 4. So I'm going to come out to the side and I'm just going to try one. I'm going to try 4 first. I want to see what that gets me. And so 5 times 4 is 20. 4 times 3 is 12 plus an extra 2. That gives me 40. All right, that one looks pretty good. And the reason why it looks so good is because it's so close to where we need to be. It's under where we need to be as well. So I'm thinking it can only go in 14 times. All right, so that takes me to that 140. And I'm going to have now a remainder of 6 left over. Okay, so this is what you have to do. This is still probably the hardest part for a lot of kids, and that's the labeling part. So I'm going to write 496 off to the side. I'm going to write 35 off to the side. I'm going to write 14 off to the side. I'm also going to write 6. But as a math student, I have to stop and think. I have to label everything here for it to truly make sense. So if I read the problem, I know a container can hold 35 of the orange slices. So this is how much the container can hold. So I'm going to label this container, and I'm just going to put an abbreviation there. That's how much a container can hold. All right, and then I know that they have 496 of these orange slices. So I'm going to write total, and then I'm just going to write OS for orange slices. I know what that means. And again, if you abbreviate, you ought to know what it means. So abbreviate it in some way that you get it. So total orange slices, that's how I would put it. And then I've got to start thinking about the rest of my numbers here. So I've got 14, I have a 6. So at this point, I have to stop and think, well, what does that 14 really mean? What does that go for? And so I have to stop and really kind of dig into this problem and think, okay, well, they're putting all these orange slices into containers. And I know that 35 orange slices can go into a container. I think my 14 here are going to be my full containers. Those are the ones that we can actually fill up. Now, the 6 is going to be my orange slices that are left over. Basically, those didn't make a container. So I'm going to write leftover, and then I'm going to write my OS for orange slices. And again, I know what that means. Okay, but the thing is, I've still got to stop and think, well, what do they want to know here? They want to know how many more slices would they need to fill up the last container. So in my mind, I'm thinking, all right, well, what do we know? I know a container can hold 35. If they want to fill up an extra container, the last container, then I have 6 orange slices left over. That was my remainder. But they don't want to know the remainder. They didn't ask how many was left over. They asked, well, how many more slices would they need? So I'm thinking, again, this is going to turn into a subtraction problem, but you have to know what to subtract. And so if it takes 35 slices to fill a container and they had 6 left over at the end, I'm thinking maybe I could take these 2 and go subtract to find out truly how many more they would need before they can fill another container. Because if I have 6 left over, that's not going to be a full container. But if I do 35 minus 6, and I think about my math there, 15, I'm going to have to regroup here, so that's going to turn into a 15. That's an ugly looking 5 up at the top. But 15 minus 6 is going to be 9. And then I'd have to borrow, and then that would turn into just 2 minus nothing. And that's how I got my final answer of 29. I think when it's all said and done, they're going to have 29 more slices before they can fill that last container. So again, a little bit different, a different type of interpreting remainder problem. So if you watch these videos, you're going to have 2 freebie answers. So if you took my advice and you need some help, maybe this is something that you could do in class to get that extra help.